Natural logs, Linux. A reminder of the conversion from exponential to log form and from log form to exponential form. So e is about 2.718. It's a value greater than 1, so the graph of e to the power of x has a positive gradient. It's an increasing function, a growth curve, and it goes through the y-intercept, y equals 1, and the x-axis is an asymptote. Now the log function linx has the y-axis as an asymptote, and it goes through x equals 1, and these are inverses of each other. So if you take e to the power of x, you reflect that graph in the line y equals x, you get its inverse function, which is linx. So typically when you're writing down a log with the base e, we write that in shorter form as ln y. So y equals e to the power of x in exponential form. In log form we start with the power, so we say that x is equal to log, we use the same base e of this value y, or shortened to ln y. Basic rules of logs. So what's ln e to the power of x? Well, we can write down this in terms of a log to the base e, and then we can move the x, which is a power, to the front, and we know that the log of some value to the same base is equal to 1, so this all gives us x times 1, which is x. So ln e to the power of x is equal to x. So in here, x is the input. It goes into the function e first. Whatever comes out goes into the log function. So the input and output are exactly the same because you have a function, and the output from the function goes to the inverse function, and they undo each other. It's like taking a number, multiplying it by 5, and then dividing it by 5. You're back to where you started, and essentially this is doing something similar. So to simplify e to the power of ln x, I've made it equal to y. This is the exponential form. So in its log form we start with the power. So power equals, here, power equals the log base e of this value y, and we know that log of y to the base e, we can write this as a natural log, so we can write this as ln y. So if we cross off the logs, x equals y there, so if my y here is equal to x, if that y is equal to x, so if I cross out the y and put x there, then e to the power of ln x is equal to x. Again, the input is x, it goes into the log function first, whatever comes out goes into the exponential function. So you have an inverse function and a function feeding into each other, they undo each other, so the input and the output are exactly the same. So e to the power of ln x is equal to x. So part A, e to the power of ln 2. So 2 goes into the log function, whatever comes out goes into the exponential function, so you have a function and its inverse next to each other, so they cancel, so the output will be 2. Okay, in this example we want the e and the log next to each other, like this. And then to the power of k, because if we do the power on power rule for indices, we're just going to multiply these two together to get exactly this. So this is an alternative but more useful way of writing down e to the power of k ln x. Now if we focus on what's inside the bracket here, the e and the ln function, inverse function, they cancel, so inside the brackets we're left with x. Okay, so in the brackets we've got x, outside the brackets we've got a power of k, so we simplify to x to the power of k. Now sometimes it's useful to change the base to e when solving problems. So if we reverse all of these steps, so starting with x to the power of k, if I just put the x in brackets to the power of k, and then e to the power of ln x, like this, to the power of k, because the e and the ln will cancel, leaving with just the x in the brackets. Then removing the brackets, I've got e to the power of k ln x. So I've changed the base from x to e, and this can be really useful, especially when using calculus, like differentiating or integrating functions. Once again, we have an input that goes into the exponential function, which then goes into its inverse, the log function. So the function and inverse cancel, so whatever goes in is the same as what comes out. Input equals output. And this is similar. We have x squared as the input into the exponential function, which then goes into the inverse, which is the log function. The e and the ln cancel out, so we're left with x squared, but there's still a times 5 there, so we have 5x squared. To work out x, take logs on each side, but because the base is e, we should take natural logs on each side. So write the word ln once on each side. So on the left hand side, the input here, 2x, goes into the exponential function. Whatever comes out goes into the log function. These are inverses, so we have 2x on the left, simplified. Then we divide by 2, or multiply by a half on each side, there. And we can simplify further. We can take the coefficient of the log term and move it up here as a power. 25 to the power of a half, or root 25, is 5, so x equals ln 5. An alternative is to raise each side to the power of a half first, and then take natural logs. To work out x, we need to get rid of the log, and if it was e to the power of ln x, then the e and the ln would cancel, but we need to do e to the power of on both sides. What you do to one side of the equation, you do to the other. And the e and the ln cancel, function and inverse, so x is equal to e squared. That's the exact answer. If this step, doing e to the power of on each side, looked confusing, think of this easier example. 8 is equal to 16 divided by 2. So, if I do 2 to the power of on each side, these are still exactly the same. And I've done something similar here. Instead of 2 to the power of, I've done e to the power of, because ln x was equal to 2. So I've raised this side as e to the power of, and I've done the same to the right hand side. To solve for x, the bases are different, so we can't add the indices here. I've taken natural logs on each side, and I'm multiplying the 3x here with the e to the power of 4x minus 1, so I can use the multiplication rule for logs to split this up into two separate log terms. And here we have a ln and an e next to each other. The input's 4x minus 1, it goes into e, that goes into its inverse function, the log function, so the ln and the e cancel, we've got 4x minus 1 left. The power of x goes to the front, so we need to simplify a little bit. We've got x in both of these terms, remove x, put it on the outside, factorize, then divide by 4 plus ln 3 on each side, and we've worked out the exact value of x. For practice, try these problems. And one last point, this simplifies to x. The x goes into the log function, and then it's e to the power of this, and the e and the ln function inverse, they cancel to give you x. In this it's a bit different. X goes into the log function, but that doesn't feed into e. It's not e to the power of here. What we've got here is more like this, e to the power of 1 times ln x. So this is not being fed into the exponential function. These are separate, so you only get e times ln x. It doesn't simplify any further.